All right. So for this one, what height he will attain, it depends what is its initial condition. Let's say if he throw from this point, this height will be different. If he throw from this height, let's try to put it like different color, maybe. If he throw in at this height or this height or this height, or maybe he throw from this height, it depends what is the initial condition. All right. Or or you can say that, let's say at time t is equals to 0, t is equals to 1, t is equals to 2, t is equals to 3, t is equals to 4, and then t is equals to 5, and t is equals to 6. So if you know what is the initial condition at t is equals to 2, what it is height h, right? So we need an initial condition to find the successive solutions at point maybe uh, in between 3 and 4. What is the height and this one? We need the initial condition. It is a similar way, like for example, if I ask someone when you gonna reach my house, so it depends on his initial condition, that where is he. If it is really close to my house, maybe he will come quickly, but if he is far, he will come really late. All right. So in these kind of problems, we are always concerned and we will have an initial condition. Initial condition will tell us what will be the solution of our ordinary differential equation. All right. So later in our lab portion, we will try to understand that how these what you say different differential equation they work and their curves, and we will try to plot different equations, set of linear differential equation using R. All right. So let's quickly try to try to solve one numerical problem. Try to solve one numerical problem that, for example, they say that use Picard method, use Picard method to solve following equation. Dy by dx is equals to x plus y squared with initial condition y naught is equals to 0. All right. So in here we also need up to first approximation, second approximation, third approximation. In here they say that up to third approximation. Let's try to write the formula very quickly. So in this particular question, sometimes you will see that instead of dy by dx, they write it y dash is equals to x plus y squared. Or sometimes they can write it maybe dy by dx minus x is equals to y squared. So you can just keep it dy by dx on one side and the remaining other side. All right. So in that case, we have this one. So let me just write quickly the formula. The formula is yn plus 1 is equals to y naught plus integral x naught x and f of x and sorry, yn and dx. All right, this is the formula. So most of the time, this one, while this one is your x naught, and this one, the y naught. These are your initial conditions that I'm going to highlight it in here. These are your initial conditions. All right. At a value of x is equals to 0, the value of y is equals to 0 as well. All right. So for example, we're going to use put n is equals to 0. If we put n is equals to 0 in this equation, we will get y1. We already have y naught. We already have the value of y naught. The value of y naught is equals to 0. All right. So now we need to find the y1. What is the y1? All right. So to get the value, we put n is equal to 0. The equation will become y n is equals to 0 is equals to and y naught and integral x naught into x, and inside it is a function, so our function is x plus y squared, so we can just write it x plus y n is equals to 0 and dx. All right, then we can just solve it. Let's say y1, we already put it, is equals to, this one is plus, so why not? You know, why not? We already know this is the initial condition, right? Plus integral x naught, you already know it is 0. This is your x, and inside you will have again maybe x, and y naught, you already know that y naught is equals to 0 and dx. So at the, if you try to solve it, this is 0 plus integral 0 x dx, so it's gonna be x squared by 2. All right, so this one will be our the y1. Similarly, we need y2 now. So if we put n is equals to 1, then we will get the y2, and y2 will be equals to, let's just put it in here, y naught plus integral x naught x, then in here we have x plus, we need to put this one equals to 1, so it will be y1. So if we put y naught, we will try to solve it, x naught integral x and x plus, and now we have y1 already. So we're gonna put this value in here, this one, and x squared by 2 dx. All right. So if ever you solve this one, if you solve this one, you know y naught is equals to 0. So just try to solve it, and you will get, your answer will be x squared by 2 if we take the derivative, because this one gonna be 0, x naught is equals to 0 in here, and x squared by 2, and it's gonna be, maybe it's gonna be, I don't know, x, because, just give me a minute. All right, so in here I think we had this function y squared. Sorry, it was y squared. You know, in the first case, it was 0, so it we did not get any error, but in here it must be squared. So once it's squared, so it should be squared as well. So it will be like x 5 over 5 if you take the derivative, because it will become 4 x 4 over 4. All right. And yes, we have to multiply it by 4 as well. So our final answer will be x squared by 2 plus x5 by 20. So this is y2. Similarly, if you further go and put n is equals to 2, then you will get y3 is equals to y naught plus x naught x plus y. This one is 2 squared dx. Should put dx in here as well. All right. So y naught is already 0 in here, and then what we're gonna have, like, integral, it's 0 to x, and inside this x is same, plus y2 is coming from there, the x squared by 2 plus x5 by 20 squared and dx. So please try to solve it. Once you solve it, you will get this, the derivative x squared by 2 already, and x5 by 20 you will get from from here, x4 over x4 by 4, you will get this one, and then you will get another term which is x8 by 160, and finally you will get another term which will be x11 by 4400. It will be like that, because let's just use the formula. Like, let's say this is your a, this is your b, so a plus b squared is equal to a squared plus b squared plus 2ab. We can use this formula and try to integrate it, and yeah, so up until like the third approximation we get the value, the third approximation. All right. So in case they ask you find also find y 0.1. So if they want y 0.1, just put the value of x 0.1 in here. So y will be equals to a third approximation 0.1 squared by 2 plus 0.1 raised to power 5 by 20 plus 0.1 raised to power 8 by 160 plus 0.1 raised to power 11 by 4. So once you solve it, you will get your answer. All right. So I think so. This is that's it for today. So maybe in our next class we will talk about some other methods as well, and we will try to solve these particular ordinary differential equation with the help of R. Okay, please take care. Have a good day. Bye.